Hello everyone, welcome all to Physics with Astronautics. So in this video we will discuss about the 2023 cpet physics paper. So let's begin. And here is the first question of this session, that is, for a conservative system, generalized force should have what? And the options are: has necessarily the dimension of force, uh, dimensionless, cannot have dimension of force, and option D is may have the dimension of torque. So we can see the solution that first of all we have to know what is generalized force. So generalized force is the any quantity when multiplied with the generalized displacement gives work done, and it's called generalized force. And here we can see delta W, which is the work done, is equal to Fi del R. So in the place of Fi we can put TdS, where ds is the generalized displacement and T is the generalized force. Again PdV, where P is the generalized force and dV is the generalized displacement, and here it gives rise to dW, that is the work done. So the generalized force can have any dimension, but in the question it has been asking that for a conservative system. So particularly for this situation, we can say that the generalized force has necessarily the dimension of force. Then Hamilton's canonical equation are, and here you can see the options, and we know that the correct option is qk dot is equal to del h by del pk, pk dot is equal to minus del h by del qk, and minus del L by del T is equal to del H by del T. So here option B is the correct answer. So here we can see, if the Lagrangian of a particle of mass m moving in a plane is L is equal to half mx dot square plus half my dot square plus xy dot minus yx dot, then px of the particle is. And here you can see the options. Again we know the formula for momentum, that is pk will be equal to del L by del qk dot. And because here we have to find out the value of px, so we can take the derivative of del L with respect to x dot, and here it will be px is equal to del L by del x dot and is equal to half into 2 mx dot minus y, and is equal to mx dot minus y. So here option C is the correct answer. Then velocity profile of the liquid flowing through a narrow tube hatch, and which shape it will follow. So the option A says circular, B elliptical, C parabolic, and option D says straight line. So here the correct option is parabolic shape, that is option C. Then for momentum to be conserved, the Lagrangian is to be of form, and here you can see the options. So the condition, we know that we can see in Lagrangian the qk dot is present but qk is absent. So in this case we can say that pk is conserved. For example, let L is the Lagrangian, and which has equation half mr square theta dot square plus sine square theta phi dot square. And here we can see that phi dot is present but phi is absent, so we can say that p phi would be conserved. So when we'll see the options, we can see here that option C, that is L is equal to half m q dot square. Here we can see that q dot is present but q is absent. So here we can see pq would be conserved. So option C is the correct answer. Here we can see, if an electron is traveling with velocity 0.98 c, the mass of the electron that appears to stationary observer in lab is. So basically this is the question of STR, and here we have to find out the mass. So we know the formula, that is m is equal to m naught by 1 minus v square by c square. So by putting all the value here, we can find out it as 5 root 2 m naught. So this is the correct answer, but because here 5 root 2 m naught is not present, so here we can take the option A, that is 5 m naught. Then the order and degree of equation x square d square y by dx square plus 2x dy by dx plus y is equal to 0 is. and here we have to find out the order and degree. So here we can see that the higher order is 2. So this is the second order differential equation, and again we'll see that the power over here is 1, that is the degree 1. So we can say that the order is 2 and degree is 1. Then Wronskian for y1 is equal to sine 2x and y2 is equal to cos 2x each. And we have to know the formula for Wronskian. So here it has been given that y1 is equal to sine 2x and y2 is equal to cos 2x. So the Wronskian, we can find it as w is equal to the determinant of y1 y2 and y1 dex y2 dex. So first of all we have to calculate the value of y1 dex. So here y1 dex would be 2 cos 2x and y2 dex would be minus 2 sine 2x. So by putting the values here, we can find that the Wronskian value would be minus 2. So here option B is the correct answer, which is minus 2. Then Taylor series expansion of e to the power minus z about point z is equal to a equal to 0. And here the options you can see. So the general form of Taylor series expansion is fz can be written as fa plus z minus a f dex a by 1 factorial plus z minus a whole square f double dex a by 2 factorial plus z minus a whole cube f triple dex a by 2 factorial and so on. So in the question it has been given that fz is equal to e to the power minus z uh, and here a is equal to 0. So by putting the value here we can see that the final result would be 1 minus z plus z square by 2 factorial and so on. So this option match with the option B. So here option B is the correct answer. Then volume of tetrahedron with sides 2 I cap plus 3 j cap minus 4 k cap I plus 2 j cap minus k cap and 2 I cap plus 3 j cap plus 4 k cap each. And the options are 4, 3 by 2, 8 by 3 and 4 by 3. So the volume of tetrahedron is equal to 1 by 6 into the scalar triple product of the sides. So here given is A, B and C, that is the three sides of the tetrahedron, and from here we can calculate the volume by putting the formula. So this would be equal to 1 by 6, the determinant of these three sides. So the final answer would be 4 by 3. So here option D is the correct option and which is 4 by 3. I hope you all enjoyed this session. So for more videos, please do like, share and subscribe. Thank you.